We've talked about renin, we've talked about angiotensin. Let's talk about aldosterone now. Aldosterone is the final hormone that gets your blood pressure to go up. And so where does it come from? Aldosterone comes from a gland. I'm going to draw it here. And the gland is actually called the adrenal gland. Adrenal gland. And this gland literally sits right on top of the kidney. And so let me draw the kidney here for you, so you can kind of orient yourself to where this gland would be sitting. And of course you have two kidneys and you have two adrenal glands. You have the left and the right. And if you were to look inside of the adrenal gland, you'd notice that actually in the middle of the adrenal gland is an area that looks different than the outside. And we call that the medulla. The inside is the medulla. And the outer bit is the cortex. And they make different hormones. And this cortex is actually the part of the adrenal gland that makes the aldosterone. So let me draw some cortex cells here for you. And in the middle is a blood vessel kind of running through. I'll draw that in just a moment. So these cortex cells are basically like any other cells. They need food, they need nutrients, they need oxygen. And so these capillaries that are running through are going to provide all of that to these cortex cells. And if you were to take a little microscope and let's say look deep within these cells, maybe not even with a microscope, but let's say you were able to look deep within these cells, you'd notice that there's cholesterol in these cells. So there's cholesterol sitting inside of these cells, actually not visible, but it is there. And the cholesterol, I've always wondered, what is the point of cholesterol? It always seems like it's a bad thing. This cholesterol is actually really useful to these cells because it helps them make the hormone aldosterone. Actually, aldosterone comes from cholesterol, and if you put the molecules next to each other, you'll see how similar they are. They actually look really, really similar. So these cells are the ones making aldosterone. But of course, you can't just make aldosterone willy-nilly. You have to wait for the right moment, right? So when does that cell know to make aldosterone? What are the triggers? Well, there are a couple of triggers. One would be if you see, or if those cells encounter angiotensin 2. So if angiotensin 2 comes around, that would be one of the triggers to let the cholesterol turn into aldosterone. Angiotensin 2, you remember, is floating through the body. It's actually quite a journey of its own, making its way from the liver initially and all the way into meeting renin and then meeting angiotensin converting enzyme. So this angiotensin 2 has been around a long time, and it finally makes its way to the cortex of the adrenal gland, and it is one of two stimulus for making aldosterone. And the other stimulus is actually not a hormone, but it's actually the ion potassium. So, blood has a lot of sodium in it, but it also has a little bit of potassium in it. And if those potassium levels start creeping up, if you have a little bit too much potassium, then that is a stimulus for getting some aldosterone out there in the blood. So these are the two triggers for getting cholesterol into aldosterone. So just keep that in mind. And let's actually now make a little space on our canvas and see exactly where the aldosterone works and how it works. So let me scroll down and let's go back. Let's think back to our blood vessel that enters the kidney. And we know that we call that the afferent arteriole, and it goes into the glomerulus, which is that little clump of blood vessels I just drew there. And the afferent arteriole and efferent arteriole, this is all review now, right, are in the kidney. These are the blood vessels that have entered, and the efferent arteriole is exiting the glomerulus of the kidney. And you remember, this is our little kidney nephron, the Bowman's capsule and the proximal convoluted tubule. Then we have that loop of Henle, and we have that distal convoluted tubule that goes like that. And then it all kind of comes together in the collecting duct. So this is the nephron, right? This is our image of the nephron. And now to answer the question of where does aldosterone work, I needed to draw this because I wanted to show you that it actually works in this area that I'm circling in blue. So this is kind of the area that the aldosterone is working on. And right here, this part right here, is the late part of the distal, so I'll call it the late distal convoluted tubule. And the other part that it works on right here is the collecting duct. So these are the two areas that the aldosterone is actually going to have an effect on. So it's going to affect the kidneys. That's actually going to also affect the gut, but I'm not going to get into that too much detail because the main effect of aldosterone is on the kidney. And so let's try to blow up some of these areas so you can see exactly what I mean. Let me draw a cell here. Here's one cell, and just imagine that you've got another cell there, another cell there, and you've got, let's say, a few cells there, and they're lining the nephron, right? They're lining, let's say, the distal convoluted tubule or the collecting duct, and these are called principal cells. Principal cells, and it's actually spelled the way that a principal at a school would be called or spelled. So this is the principal cell, and on the other side of it, over here, you've got blood flowing. And you remember we talked about the peritubular capillaries. Peritubular capillaries. Well, this is where it comes into play. Peritubular capillary is actually sitting next to the principal cell, and blood is flowing through here. Blood is flowing through, and of course, this is filtrate, or what will soon be urine, is flowing through here. So we've got blood and urine flowing through, and we've got a couple of surfaces here, right? So we've got one surface here, and this is called the basolateral surface. And this becomes really important because the surfaces are where ions are going to be dancing back and forth. This is the other surface, this is the apical surface. Apical surface. So this is the surface between the principal cell and the filtrate, or the urine. Okay, so we've got a couple surfaces, we've got a cell, and we've got some blood, urine. And now you remember that most of the inside of these cells is going to be loaded with potassium, right? So there's a lot of potassium in here. And if this is another principal cell, there's more potassium in here. And the blood is going to have a lot of sodium. So let me draw sodium over here. So a lot of sodium in the blood, that's the main solute, and a lot of potassium in the cells. And now these aren't the only ions in the blood or in the cells. These are the main ion in the blood and cells. So just keep that in mind. They're not the only ones, but they are the dominant ones. And so what happens is that the cells want to maintain this gradient, right? This is always the case. They always try to maintain this gradient, and they have this wonderful sodium-potassium pump to do it, right? They have this pump that basically gets 2 potassiums over here, and it squeezes 3 sodiums out over here, right? So we have this sodium-potassium pump. 3 sodiums. And this pump does not come for free, right? Because it takes energy to get things to go in a direction they don't want to go. So this is actually going to take ATP to drive that pump. So now, so far, I haven't actually mentioned aldosterone. Where does aldosterone work? Where we know it works in the principal cell, but what does it do in the cell exactly? Well, it does 3 things, okay? So 3 things. One, I'm going to write it really clearly, is that it drives that sodium-potassium pump to work harder. Okay, so it basically is going to get even more potassium in the cell and even more sodium over into the blood. So far, so good, right? Second thing it does is it puts in little potassium channels here. Well, that's interesting because we know that the cell's got a lot of potassium in it already, right? So if you have a potassium channel, if that's the second thing that aldosterone does, number 2, what do you think is going to happen with that potassium in the cell? Where's it going to go? Well, it's going to see that channel, and it's going to say, well, I'm out of here. I'm going to go into that urine because there's a lot of potassium in the cell already, and it wants to get over to a place where there's less of it. So it's going to go over to the urine side. So potassium is going to leave the cell. Well, that makes it easier for that pump to work harder because now it's going to squeeze even more potassium into the cell, right? This is going to work even harder to get potassium in there because this potassium is leaving and getting into the urine. So really, at the end of the day, what happens is that the blood, I'm going to write it over here, kind of the net effect, the blood is going to, one, it's going to lose potassium, right? Aldosterone is going to make the blood lose potassium. And that makes perfect sense because keep in mind, one of the triggers for aldosterone was high potassium. So this is a perfect kind of system to now lower your potassium. It's a nice little loop that you've created, right? More potassium, no problem, make some aldosterone, and aldosterone is going to help you lose some of that potassium. Okay, now going back to aldosterone, what's another thing that it does? Well, it does this. It puts in little sodium channels. This is a third thing that it does. Now, if you have a little sodium channel, let's try to think through what would happen. Sodium is going to make its way into the cell, right? Because it's going to say, well, there's not much sodium in there, so I might move into the cell. So sodium gets into the cell. And then again, that sodium-potassium pump says, aha, sodium in the cell? Great, let's pump it into the blood. So it's actually going to move from the cell over into the blood, and that ATP is going to be used up. So it definitely takes energy to do this. But at the end of the day, you're going to move sodium from the urine, what would have been urine, to the blood. So another effect, another key effect, is gain of sodium. Gain of sodium in the blood, right? And think through this. Now, if I said at the beginning that the main solute in blood is sodium, right? That's the main way that it's attracting water through osmosis. And now you have more of it, you have more sodium. Well, then water is going to also get pulled into the blood, right? It's going to get pulled into the blood as well. And so this is the other key thing that happens. You gain sodium and water. And this is important because, remember, the renin-angiotensin-aldosterone system, the whole point of it was to raise your blood pressure. Well, now you can see how it actually works because the aldosterone is going to pull in more sodium into the blood, and then water is going to follow, and all of this stuff is going to lead to increased volume or increased stroke volume. And remember, stroke volume relates back to blood pressure and therefore blood pressure. So this is how aldosterone works. It allows you to drop your potassium. It allows you to raise your sodium. The sodium pulls in some water, and the water helps you raise your blood pressure because of extra volume, extra stroke volume. So let's pause right there. We'll pick up with some more stuff that aldosterone does in the next video.